Last class we deal with some problems, and at the end of the video I give you a problem to solve this at your own. I hope you guys done it correctly. In this video I will solve this problem, and further we go for residue problems or residue theorem. So first a matrix is given and an identity matrix 2 into 2 cross 2 matrix is given. Find the value of AQ. So options are given. First you have to give the formula. You have to know the formula for finding the eigenvalues. A minus lambda I mod of A minus lambda I is equals to 0. Putting the value of A and I, we get minus 5 minus lambda minus 3, obviously mod 2 minus of lambda is equals to 0. This is our A minus lambda I. Then we determine this minus lambda into this will you get as 5 plus lambda plus 6 is equals to 0. Now you have to multiply lambda, we get lambda square. 5 lambda plus 6 is equals to 0. After this we take the lambda as a, let lambda, so putting the value of lambda a square plus 5a plus 6 is equals to 0. Oh sorry, I have made a mistake. This is 6i, this will be 6i and this will be 6i. Now a square is equals to minus 5a minus 6i, because I is the identity matrix. So after that we get a cube is equals to minus 5a square minus 6a. Now putting the value of a square, we get a cube is equals to minus 5 minus 5a minus 6i minus 6a, and if you calculate this you will get 25a plus 30i minus 6a. So we get 19a plus 30i. 19a plus 30i. Check the options. 19a plus 30i is given or not. So 90a plus 30i is given. So the correct option is B. Now for residue theorem, the closed integral of fz dz, C is a point, z minus a is equals to r, radius, where r greater than 0, and z will be x plus iy. Complex format, a will be a1 plus ib1. Then after we take mod, then we get x plus iy minus a1 plus ib1 is equals to r. After that root under of, we putting the value of a, x minus a1 plus I into y minus b1, we get it as the points of the circle. So after that we take the radius of this, we get x minus a1 whole square plus y minus b1 whole square is equals to r. So we get it as x minus a1 whole square plus y minus b1 whole square is equals to r square, where the points are a1 and b1. In this problem we have to make qz fz equals to pz by qz, where qz is equals to 0. Then the value of the z function is not analytic, called as singular point, and we have to calculate the pole. A pole whose pole of order 1 is called simple pole. Alpha is the pole, so in a simple pole the formula of residue will be residue of alpha is equals to limit of z tends to alpha, z minus alpha fz. And if alpha is a pole in order of n, then residue of alpha is equals to 1 by m minus 1 factorial limit z tends to alpha d to the power m minus 1 dz to the power n minus 1, this is m minus 1 z minus alpha whole to the power m fz. This is the two formulas you have to remember. Now a problem, fz is equals to sin z divided by z square, where pole z is equals to 0, then the residue of this will, you have to find it out. So for closed integral of fz dz, where fz is the sin z divided by z square, you have to know which residue formula will be applicable. So at z equals to 0, so our alpha will be 0. So residue of 0 is equals to m means 1 factorial limit m minus 1 will be 1 factorial z tends to 0 d dz of sin z divided by z square, and here z square will be multiplied, so z square will cancel out, and we get limit z tends to 0 cos z. Cos 0 is 1, so our answer is 1. So the residue of this will be 1. So in the next problem, the residue of the function is given at z is equals to 2. So point is given. So you have to remember the two formulas, which formula will be applicable for this. So number 2 formula will be applicable for this. So we get residue of 2 is equals to m minus 1 2 minus 1 factorial limit z tends to 2 d dz of z minus 2 whole square into 1 divided by this f of z, means z plus 2 whole square and z minus 2 whole square. Then we will get z tends to 0, this will be 1, d dz of, this will be both cutting out, z plus 2 whole square, and you will get if you equate this, then you will, and putting the value of z, you will get 1 divided by 30 minus 1 divided by 32, because to the if go differentiate this, if it is go upside, you will get minus comes out, then the answer will be minus 1 by 32. So in the next problem, a function is given fz is equals to 1 by z plus 1 minus 2 divided by z plus 3. Find the value of where c given, where center is minus 1. Find the value of 1 by 2 pi I close integral fz dz. So first you have to evaluate this 1 divided by z plus 1 minus 2 divided by z plus 3. If we multiply this, then z plus 3 minus 2z minus 2 z plus 1 and z plus 3. So you will get minus of z plus 1 divided by z plus 1 z plus 3. So we get z is equals to minus 1 and minus z is equals to minus 3. So the minus 1, center is minus 1, so we will take minus 1, center at 1, so we will take minus 1 inside. So residue of minus 1 will be, alpha is minus 1, limit z tends to minus 1 z plus 1 z minus of z plus 1 divided by z plus 1 and z plus 3. Z plus 1 z plus 1 cancel out. If you putting the value of minus 1, you will get 2 divided by minus 1 plus 3 as 1. So answer is 1. Find the value of 1 by 2 pi I integration of fz dz, you will get it as 1. So this is the problems on residue. You have to try this at your home, solve this. If you have any problem, please comment below. Till then, keep watching and keep learning. In the next class, we will solve some more problems on residue. Thank you.